HB200 balancing machine. So this is a horizontal axis balancer. There's two balancing cradles, and I'm going to take your part and then load it into the balancing machine here. So the end stops are set to keep the shaft from moving left to right, and the drive belt I'm going to put on. I'm going to thread it through the belt idlers like this, and I'm going to flip the belt idler switch from off to on, and this air cylinder will now put tension on the belt. There's a mark that I put on this arbor, a black line that's going to trigger on our photo sensor. So that output trigger is the RPM sensor plus our 0 degree reference, and that'll determine where the unbalanced locations will be. At this point, I am ready to start with the parameter setup. So I'm going to click Edit Part, and here we have different parameters. We have an A, B, and C dimensions that are referenced to this diagram here that we will show on the, I'll show how we put those numbers in right now. So our A dimension is a dimension from the location where we're going to make our balance corrections on the left side to the center of the left bearing, and that is at 3 inches. Our B dimension is the right plane center to the center of the right bearing. That's 2 1/4 inches. Our C dimension is the distance between the bearings centers, which is 9 1/4 inch. So I'm going to go over here and show you, these are the numbers that we have. I have this already saved. So 3 inches, 2 1/4, 9 1/4. The correction radius is where we need to make our balance correction. And that is from the center of the shaft out to the center of where we're going to be making our part, where our correction here. And so that is 3.875 inches. So I have that set for the left correction radius and the right correction radius. I'm going to use this ISO 1940 calculator to use the quality grade G6.3. I plugged in 39.5 pounds, which is the weight of the rotor, and assuming we're spinning it at 1800 RPMs, once I click this box here, it calculates the amount of ounces at that radius for both the left and right side. So our tolerance is 0.107 ounces at the radius. And we have this set to show us where to add weight as opposed to remove weight. We're going to be taking a run time of 4 seconds, and at this point I'm going to click Apply, and we're ready to run. It's going to spin for 4 seconds. I'm going to take a balance reading, and so that's how much the part is out of balance. That's what I need to add. And so this red number here is the encoder, which basically aligns top dead center with the part. So I'm going to move this to 132 degrees. I'm going to do my left side first. So when these two angles are correct, or in line, I'm going to add my balance weight. Now I've taken your weights, and I'm just basically just going to use a little clay to hold them in. A 1/2 ounce and a 1/2 1/4, which is approximately 1/8, which will equal 0.625 ounces rather. I'm going to put it at the location where it's asking for here, top dead center, as close to the angle as I can, and stuff those in there. You would actually peel back the backing and just stick them up there, and that's how we balance it. On the right side, I'm going to move this to angle 129, and I'm at 0.364. I've got a 1/4 ounce weight plus another 1/8 ounce, and I'm going to stick those right there. Again, top dead center, wherever that red encoder number is, that's where I'm making my balance corrections. Press the start button. Part is going to come up to speed. Take the balance run for 4 seconds, and there we have it. We are now below the balancing tolerance, so both sides say pass.